Hello everyone, my name is Edward Johnson. I study at the Federal University of Goiás, and I'm presenting MathVR, a work-in-progress VR tutoring system that combines multi-model interaction with an LLM-driven tutor for mathematics learning. VR has strong potential for math education because it supports immersion, engagement, and interactive visualization. However, many existing VR learning apps behave like interactive content viewers where they rely on fixed lessons and predefined questions, and they lack deep adaptive conversational guidance. LLM tutors can explain concepts very well, but in math, some questions need the learner to draw a diagram or show work, not just describe it in words. Although those things can be drawn and sent to a tutor, it is inconvenient to draw with a mouse. MathVR targets that gap by combining conversation with sketching inside VR. MathVR places the learner in a virtual classroom with three core elements: a virtual tutor, a whiteboard, and a virtual sheet of paper on the desk for handwriting and sketches. The learner interacts using speech and handwritten input, and the tutor responds using step-by-step scaffolding, meaning it guides the learner with prompts and hints instead of immediately giving the final answer. A key feature is that the tutor can synchronize verbal explanations with visual output by projecting content onto the whiteboard during the dialogue. When the model outputs text inside tags, that tagged content is extracted and rendered on the visual whiteboard. So in the example on the right, a user asks a question about the Pythagorean theorem. The MathVR tutor responds with an initial tag that gets displayed on the whiteboard. Then he talks via TTS up until the next tag. At that point, he does a small pause and updates the whiteboard and continues talking. This mimics how a teacher can use content on a whiteboard to enhance their explanation, having the student maintain a constant visual on the important formulas or concepts they need to remember. Each new tag updates the whiteboard to show the current most important formula or concept. The image below shows the final content in the whiteboard. This makes the session feel closer to the real tutoring interaction where the tutor can talk and write in tandem. Because the output is freeform, tags are validated with a regex-based checker, and small formatting issues are corrected automatically when possible. When automatic fixes are not possible, we call the Gemini API directly to fix the tag, although we have never had tags that weren't able to be fixed automatically in our tests. The pipeline is a closed loop. The learner speaks and we transcribe using Whisper. The transcribed speech plus sketch content is sent into a conversational module built with the Google Agent Development Kit using Gemini 2.5 Flash as a tutor model. The tutor generates scaffolding dialogue and optionally tagged whiteboard content. The response is spoken using 11 Labs TTS and rendered through a MetaHuman avatar. We ran a pilot with 12 university STEM participants, ages 19 to 26, using Unreal Engine 5.5.4 on a MetaQuest 3. The goal was feasibility and usability, not measuring learning gains yet. The feedback from this test was used to update some of the functionality and fix bugs for our real user test. Quantitatively, we tested the pipeline on 50 high school level math questions across 5 categories, plus 10 impossible questions. Both the full pipeline and direct Gemini API solved all solvable questions and correctly flagged the impossible ones. The motive for adding impossible questions was to simulate a student writing something incorrectly or proposing a question with no solution. The results are expected behavior, but still important to make sure that our system didn't deteriorate compared to raw Gemini API calls. Qualitatively, participants reported the system was easy to use and that combining audio explanation with whiteboard writing improved understanding. Main limitations were drawing and erasing precision with controllers and requests for pacing controls like skipping ahead or interrupting. Participants who had already used VR headsets and controllers before didn't have much issues with drawing and erasing, but participants who had barely or never used VR had issues. Some participants would make questions to refresh their memory and have their questions answered in the beginning of the tutor's response. The issue is that they would need to wait until the tutor finished to make another question, which could take up to a full minute depending on the complexity of the question. Now I will show a short demo.
Hi there. If you have any questions about math, just let me know. You can move with the joysticks and hold the A button to send me a question. If you like, you can also use the paper to show me your work or even draw out your question using the triggers.
I need to find the area of the triangle. Right now, I don't have the base, but I have the height, which is 4, and then the hypotenuse, which is 5. I've drawn it out on a piece of paper for you. Can you help me find the area?
Let me think. Absolutely. I'd be delighted to help you find the area of this triangle. The image shows a right-angled triangle. You've given the height as 4 and the hypotenuse as 5. You've also marked the base as x. To find the area of a triangle, we need the base and the height. We have the height, but we need to find the length of the base, x. Do you remember the Pythagorean theorem? It relates the sides of a right-angled triangle.
Yes, I do remember it. I've written down the theorem, and I've also changed the values from the original to match my problem. Is this correct?
You've got the Pythagorean theorem exactly right, and you've substituted the values perfectly. The theorem is you've written. This is wonderful. Now let's calculate the squares of 4 and 5. Do you know what 4 squared and 5 squared are?
Yes, I do. I have written down the power of 4 and then the square root of 5 as well. Is this correct?
I'm forming a response now. You did a fantastic job calculating 4 squared. That's definitely 16. However, it looks like there was a small mix-up with the 5 squared. Remember, 5 squared means 5 multiplied by itself, not the square root of 5. Let's correct that part together. We need to calculate 5 multiplied by 5. This gives us 25, so the equation should be.
Yes, it does. So I subtracted both sides by 16, and then with the result, which is 9, I got the square root of that. So the final answer is 3. Is that correct?
You are absolutely right. You've done an amazing job. First, we subtract 16 from both sides of the equation. This isolates x. This gives us x 9. Next, we take the square root of both sides to find x. The square root of 9 is 3, so x are 3. Now we have the base of the triangle, which is 3. Remember the formula for the area of a triangle? It's 1, 2, cap base, height. What do you think the area of this triangle is?
To conclude, MathVR suggests that combining VR immersion with LLM-driven scaffolding dialogue plus multi-model input can support a more engaging tutoring experience for mathematics. Next steps include testing with school-age learners to measure learning outcomes and cognitive load, and moving closer to full ITS behavior with student modeling, adaptive feedback, and progression tracking.